Okay, welcome you all. Today I'm going to introduce uh, a guest. He is Mr.Lone. Today he is going to sing a song. What is the song? The Story of My Life. One of my favorite songs. However, he is going to say his story. However, by the way, it's a lone pair. He can't talk, so I will be the translator of him. Okay. So I will explain his life by using two titles. First one is Hybridization of lone pairs and contribution for aromaticity or aromatic compounds. So many students, especially in university students, there is a very big problem. How can we identify the hybridization of a lone pair? Sometimes lone pairs may be sp3 hybridized, sometimes it will be sp2 hybridized, sometimes it will be non-hybridized. It will appear as a unhybridized p orbital. So it's somewhat confusing. So today I'm going to explain this phenomena. So don't be afraid. After this video, every problem will be solved. So I will explain everything. So now instead of Mr. Lone pair, I will explain everything. So I will erase this. You will blame me because in the thumbnail I inserted Mr. Lone pair. However, now I erased him. So I will explain these two phenomena. Okay. To explain this phenomena, initially I will use example. More common example is water, H2O. What do you know about water? Central atom is oxygen, so it has two single bonds for hydrogens, two hydrogen bonded to oxygen, and oxygen contain two lone pairs. However, the hybridization is of oxygen in this water molecule is sp3. That's the basic thing, we know that. So these lone pairs also sp3 hybridized in water. These bond pairs also sp3 hybridized. So it's a basic thing. So what about ammonia? Another example is ammonia. It has 3 NH bonds and nitrogen contain one lone pair. What is the hybridization of ammonia? The central atom is nitrogen, hybridization is sp3. This lone pair also sp3 hybridized. This bond pairs also sp3 hybridized. So these are the preliminary informations you should know about this. So I'm going to draw another example, somewhat different, that may be confusing. Okay. H3C, C, carbon contain double bond for oxygen, so it is carbonyl group. Here nitrogen and it contain two hydrogen. So I will erase water molecule. So this oxygen has two lone pairs, this nitrogen has one lone pair. So what will be the hybridization of this nitrogen? I only consider this nitrogen, not oxygen. Hybridization of nitrogen here is sp2. What? You will ask sudden question. You said previously ammonia in nitrogen is sp3 hybridized. It contains 3 sigma bonds and one lone pair. Here, this nitrogen also contains 3 sigma bonds and 1 lone pair. What is the difference? This should be sp3. You must argue with me. However, there is a very strong reason for that to be sp2 hybridization. What is that? Carefully look at this structure and what is the difference between these two molecules. If you carefully observe, you can see this carbon-oxygen double bond is one space away from this lone pair. In other words, distance between this 5 bond and lone pair is one single bond. So double bond and the lone pair is separated from one single bond, one space. In other words, I will write it down. Very special phenomena. The lone pair of an atom is situated one space away from a 5 bond. The lone pair of an atom in the same molecule, okay? In the same molecule. In the same molecule, lone pair of a particular atom is situated one space away from a 5 bond. Like here, this lone pair is situated one space away from this 5 bond. Here sigma bond and other one is 5 bond. So what will be happen here? The nitrogen is sp2 hybridized. So nitrogen contain one sigma bond and one sigma bond, all together 3 sigma bonds. 3 sigma bonds mean that's the sp3 hybridization. Remaining lone pair is unhybridized. Or not hybridized. So it will be remain as two pi electrons. This lone pair is unhybridized because of this reason. This is a rule of thumb here. That is, if a lone pair of an atom is situated one space away from a 5 bond in the same molecule, that lone pair is not hybridized. So it will remain as a 2 5 electrons. Remember this rule, it will be very useful in these situations. Okay, I will erase these molecules. Okay, so why is if it is unhybridized, if it is a 5 electron, what will happen here? Very special phenomena, that 5 electrons can donate to this adjacent carbon and its 5 bond will heterolytically cleavage towards oxygen. So in other words, it will be formed resonance structures. So if I draw resonance structure of this, I will erase this ammonia. Now we got the thing, so we don't need ammonia anymore. However, after donating this 2 5 electrons to this carbon, and this double bond will, 5 bond will cleavage towards oxygen. Now the molecule will be H3C, carbon, here previous sigma bond. Now this 5 bond was broken, so that 2 5 electrons goes to oxygen. So this is the previous, these are the previous lone pairs. Now due to breakdown of that 5 bond, that lone pairs also goes to oxygen. Now oxygen has a excess electron, because of that oxygen get negatively charged. So that's it. This is the previous carbon nitrogen sigma bond. However, now this lone pair donated to this carbon, it will form a double bond and nitrogen will be here. These are the previous hydrogen. What happened? Lone pair donated to this carbon and it formed a 5 bond. So these are the resonance structures of this molecule. We can get one conclusion. What is that? To form resonance structures, there should be conjugated 5 electron system. So to form resonance structures, the 5 electron should be in conjugated form. What is the conjugated form? Multiple bonds. In between multiple bonds, there should be only one single bond. Multiple bonds separated by one sigma bond. So these are continuous like this, one by one. So this, if the multiple bonds situated like this, multiple bond, single bond, multiple bond, single bond, multiple bond, single bond. If these double bonds arranged like this, these can break like this and it will form resonance structures. What will be the result? Here, because of this heterolytic cleavage, this carbon will get positive charge. Now it's have only single bond. This 5 bond cleavage towards this carbon and it will form new 5 bond between this carbon and this double bond broken, and it will form new double bond, and this will form one single double bond like this. Likewise, it will be broken. So this carbon get negatively charged. So however, what happened? The electron cloud localized. So not localized, delocalized. Delocalized electron cloud is a clue for the resonance structure. So if a particular compound form resonance structures, the electron cloud will be delocalized. So I'm not going to explain about resonance structures or this delocalizing phenomena. It is another title. I will explain it later. However, here the thing is, we have to understand, if a lone pair of an atom situated one space away from a 5 bond in the same molecule, that lone pair is not hybridized. It will remain as 2 5 electrons. So that 5 electrons will contribute for the conjugation. Because of that, this lone pair is unhybridized. Ammonia the lone pair of ammonia is hybridized. This is not. So you have to remember this rule. If you remember this rule, everything is okay. We will discuss some examples. Okay. What about this? Here carbon. This carbon has a negative charge. What will be the hybridization of this lone pair? Now please go to this rule of thumb. What is? If a lone pair of a particular atom is situated one space away from a 5 bond in the same molecule, that lone pair will be unhybridized, not hybridized. So here this lone pair is 1 bond away from this 5 bond. It obeys the rule of thumb here. So this lone pair is not hybridized, not undergo hybridization. So it will be remain as 2 5 electrons. Keep that in mind. So if the lone pair is remain as 5 orbital, other parts of that carbon will be hybridized. This carbon will be sp2 hybridized. Lone pair is not hybridized. What about this? Now this. Again, this carbon has a lone pair. Can we apply this rule of thumb? One lone pair should be away from a one space, one single bond. Here 1 2, it is away from 2 bonds. If it's away from 2 bonds, we can't apply this rule of thumb. So it is not valid. So this lone pair has to hybridized. So with lone pair, other parts of carbon will be hybridized. So hybridization of this carbon will be sp3. Can you understand that? This is the rule of thumb. Lone pair should be one space away from the 5 bond. If so, it will be not hybridized. Remaining part of the carbon will be hybridized as sp2. That's the theory. Okay. We will move on to another example, which is related with the aromaticity. Pyrrole. Now what about this? Now I am going to introduce another rule. When we apply this first rule, we have to think about a second rule also. What is that? I will introduce. Check whether the lone pair bearing atom, check whether the lone pair bearing atom is directly connected to a 5 bond or not. What is that? We have to check the lone pair bearing atom we are considering is directly bonded to the 5 bond or not. You will understand when I explain. So here the lone pair bearing atom is nitrogen. Here I say check whether the lone pair bearing atom, see here it is nitrogen. is directly connected to a 5 bond. Here 5 bond connected to this carbon. This carbon and this carbon, this carbon and this carbon. Any 5 bond didn't connect for the this nitrogen. So this second rule is can't apply. So it is not connected. So the answer is not connected. If so, if not connected, apply first rule. If yes, don't apply first rule. What's that? What is the first rule here? First rule is if a lone pair of an atom is situated one space away from a 5 bond, it is not hybridized and it will remain as 2 5 electrons. What is the second rule? If the lone pair bearing atom is directly connected to a 5 bond, if it is yes, if it is connected to a 5 bond, don't apply for first rule. It's another thing. If it's not connected for the 5 bond, we have to apply first rule. So here this nitrogen lone pair bearing atom is not connected for a direct 5 bond. So we can apply first rule according to this. First rule is lone pair of atom is situated one space away. So this lone pair bearing atom is situated one space away. Here 1, here also 1. In both sides is one space away from the 5 bond. So if so, this lone pair is unhybridized or not hybridized. It will remain as 2 5 electrons. If so, if it's behave as a 5 electron, it can contribute for this 5 electron system. It will form resonance structures with these double bonds also. It will be conjugated. So that resonance structures will be formed because of that. So what about the aromaticity? When we talking about aromaticity, there are 3 major requirements should fulfill. What are them? Aromaticity. To be aromatic, first one is the molecule should be cyclic and planar. It should be planar. This is the first one. Second one is system should fully conjugated. System should fully conjugated. That means closed five electron ring. It will be formed closed 5 electron ring like here. Third rule, it should obey Huckel Rule. Huckel's rule. What is that? 4n plus 2 rule. I will explain them. So according to this molecule, we apply first rule. Is it cyclic? Yes, it is cyclic. Is it planar? To be planar, to be a planar molecule, all constituent atoms. So all atoms in the ring should sp2 hybridized. We know in sp2 hybridization the geometry is trigonal planar. So it is planar. If all atoms are sp2 hybridized, the molecule will be planar. So here nitrogen also sp2 hybridized, because this lone pair is unhybridized, other should be hybridized. So this nitrogen is sp2 hybridized. This carbon, then all 4 carbons are sp2 hybridized. So it is planar. It obeys first rule, cyclic and planar. Because all are sp2 hybridized mean it's planar. First rule is okay. Second, 5 system should be fully conjugated. Fully conjugated means throughout the ring 5 electrons should conjugated. There should no any spaces. Likewise this. Consider this. This contain only 2 5 bonds. So these 4 carbons are sp2 hybridized and this carbon is not sp2 hybridized, so it doesn't contain, it is sp3 hybridized. Here it doesn't contain any lone pairs or anything, so this 5 electron cloud limited for this 4 carbons. There is no closed electron shell. This is an open system, open pi system. To be aromatic, that should be closed 5 electron system. Likewise this. Here all are form closed 5 electron system or ring. So second rule also obeyed. Third one is it should obey Huckel Rule. To be fulfill Huckel Rule, it should contain 4n plus 2 number of 5 electrons. If n equals 0, I will write it down here. If n equals 0, then 4 into n is 0, answer is 2. If n equal 1, that will be 6. If n equal 2, that will be 10. If n equal 3, that will be 14. If n equal 4, it will be 18 likewise. So here this lone pair is donate 2 5 electrons to this. There are 2 5 bonds. 2 5 bonds mean 4 5 electrons. Altogether 6 5 electrons. So if it's obey Huckel rule, this number of 5 electrons should be there. Here 6. If n equal 1, when n equal 1, it will be have 6 5 electrons. So it obey the Huckel rule. Third requirement also fulfilled. This is aromatic. No doubts. Okay. Aromatic. Now our second example. Pyridine. In pyridine, nitrogen contain a lone pair. We have to check second rule of thumb. Check whether the lone pair bearing atom is directly connected to a 5 bond or not. Here, lone pair bearing atom is nitrogen. It's directly connected for a 5 bond. If it is directly connected for a 5 bond, if yes, don't apply first rule. Don't apply first rule of thumb. So we will stop here. We have to think here. What is that? This nitrogen already donated. It's already donated 1 5 electron to the conjugated system. It's already donated its 5 electron for the conjugation system of 5 electron cloud. So this lone pair should not contribute for the 5 electron system. So if it's directly connected for a 5 bond, this lone pair should hybridized. It should hybridized. So this nitrogen has sigma bond, and this lone pair also hybridized. So only one 5 bond, that means this nitrogen is sp2 hybridized. All other 5 carbons are sp2 hybridized. So now we will check whether it is aromatic or not. What is the first thing? To be aromatic, this should be cyclic and planar. Here it is a cyclic, we can see that. Is it planar? To be planar, every atom in the molecule should be sp2 hybridized. Here nitrogen sp2 hybridized and other 5 carbons also sp2 hybridized. So it is planar and cyclic. First thing is okay. Second one, system should fully conjugated or close 5 electron ring. Here there are 6 5 electrons, 3 5 bonds, 6 carbon, 5 carbon and 1 nitrogen atom. So all are fully conjugated. So it will form a closed ring structure of 5 electron. So it will obey second requirement. Third one, is it obey the Huckel rule? To find out the Huckel rule, we have to calculate the 5 electrons in this molecule. Here there are 3 5 bonds. 3 5 bonds mean 6 5 electrons. So according to the Huckel rule, when n equal 1, 5 electron can be 6. So it will be obey Huckel rule. So third requirement also okay. Now it is aromatic. Okay, this is aromatic. Now by combining these two phenomena, I will draw this example. What about this? If we consider this nitrogen, according to the second rule, the lone pair bearing atom is directly connected to the 5 bond, this nitrogen. So we can't apply first rule. So this lone pair should hybridized. Why is that? The reason, this nitrogen already donated 1 5 electron for the 5 system. So this lone pair should not included to the conjugated system because it's already donated 1 5 electrons. So lone pair should hybridized. This nitrogen contain 1 sigma and this lone pair, it is collectively sp2 hybridized. What about this nitrogen? We have to check second rule. Is the lone pair bearing atom is directly connected to a 5 bond? Is it or not? This nitrogen doesn't have any 5 bond. So if not, we can apply first rule. Lone pair of an atom is situated 1 space away from a 5 bond. So this lone pair is situated 1 space away from 5 bond. So first rule is obeyed. So this lone pair not hybridized. That means it will remain as 2 5 electrons. Remaining things of that nitrogen will be hybridized. So this sigma, 3 sigma bonds and this nitrogen will be sp2 hybridized. What about other carbons? This is sp2, this is sp2 and this is sp2. Now all are sp2 hybridized. Now can we apply for the aromatic? We will check. Is this cyclic and planar? Yes, it is cyclic. Is it planar? Yes, because every atom is sp2 hybridized. So first phenomenon is obeyed. So second one, system should fully conjugated, closed 5 electron ring. Here 2 5 electrons, here 2 pi bonds, all are formed fully conjugated system and fully closed ring structure. So it's obey the second requirements also. What about the Huckel rule? Again, this has 2 lone pair, 2 pi electron and 2 pi bonds, that means 6 pi electrons. That means when n equal 1, it will obey the Huckel rule. So it will be obey Huckel rule. That will be, because of this, it fulfill major three requirements. It will be aromatic. This is also aromatic. Now I am going to draw my final example. That will be the end of the video. Sulfur, oxygen, what about this? Now there are several atoms, sulfur and oxygen. What about this? These are carbons. Carbon has there are 4 carbons. They have 2 pi bonds. What about this sulfur and oxygen? What is the hybridization of them? In previous examples, we found only one lone pair bearing atom, but here one atom bearing 2 lone pairs. Doesn't matter, we have to consider only one lone pair. We have to consider only one lone pair. Other lone pair, we don't care, it will be hybridized. So if we consider, you can choose any lone pair from this 2 lone pair of a particular atom. So in sulfur, I will choose this. You can choose this lower one also, doesn't matter. I will choose this. Now I will apply second rule. Check whether the lone pair bearing atom is directly connected to a pi bond. Is this sulfur directly connected to a pi bond? No, not connected. If so, we can apply first rule. Lone pair of atom is situated 1 bond away from a pi bond. Is this lone pair situated one space or 1 bond away from pi bond? This is the pi bond. Yes, 1 away in both sides. So if it is 1 bond away, that considered lone pair is not hybridized. Every part will be hybridized, including this lone pair also. So this sigma bond and this lone pair will be hybridized. The sulfur will be sp2 hybridized. This lone pair unhybridized. This lone pair sp2 hybridized here. Now you can understand. What about this oxygen? Same phenomena. It is not connected for a pi bond directly, so we can apply first rule. Lone pair, our selected lone pair, we have to select only one lone pair. There may be 1 lone pair, 2 lone pair, 3 lone pair, any lone pairs. However, we have to select only one. If we choose one, others will be hybridized. We have to apply first rule. This lone pair is 1 bond away from this pi system. From both sides, 1 bond away. So if it is 1 bond away, that will be not hybridized. And others will be hybridized, including this lone pair, this sigma bond, this oxygen will be hybridized as sp2. So this lone pair also sp2 hybridized. Our chosen lone pair will be not hybridized. It will remain as 2 pi electrons. Here it will remain as 2 pi electrons. Now, is it aromatic or not? Think about this. Is it cyclic or planar? Cyclic and planar? Yes, it is cyclic. Is it planar? To be planar, every atom in this molecule should sp2 hybridize in this ring. Here, sulfur is sp2 hybridized. Oxygen also sp2 hybridized. These 4 carbons also sp2 hybridized. All are sp2 hybridized. That means first test is passed. Cyclic and planar. So what is the second thing? System should fully conjugated or close pi electron ring. Here this lone pair will be donated for this pi electron cloud. It is 1 space away. This lone pair also 1 space away. This one, they will be contribute for the pi electron system. they will form fully conjugated system and closed 5 electron ring. Second rule is okay. Now we will apply Huckel rule. According to the Huckel rule, there should be this number of 5 electrons. Here, this lone pair donate 2 5 electrons. From sulfur, from oxygen, another 2 5 electrons. From 2 5 bonds, they will donate 4 5 electrons. Altogether, 8 5 electrons. According to the Huckel rule, there may be 6 and 10. In between, there is no number of 8 number, no 8 value. So that may we have to conclude this is not obeying Huckel rule, but it will obey another rule, that is the 4n rule. If n equal 0, 4n equal 0, pointless. If n equal 1, 4n will be 4. If n equal 2, 4n will be 8. If n equal 3, 4n will be 12. If some atom is planar, if a particular molecule fulfill these two requirements and plus 4n rule, not Huckel rule, 4n rule plus this cyclic and planar fully conjugated system, these 3 rules, it will be anti-aromatic. So here it contains 8 5 electrons. 8 5 electron means when n equal 2, it will be 8. So it will obey 4n rule, not Huckel rule. Huckel rule means 4n plus 2. It will obey 4n rule. If it is obey 4n rule with these 2 preliminary requirements, it will be anti-aromatic. Okay, so this is anti-aromatic. There is another thing, it is the non-aromatic. What is non-aromatic? It is very easy. If a molecule here, every time I meant by a molecule is a ring structure. We only considered rings, okay, in aromaticity. So if a molecule or ring is not planar, that is non-aromatic. Planar means it has at least one sp3 hybridized atom. It is not planar. So if particular ring is not planar, it will be non-hybridized. So that is the story of lone pairs, hybridization and their contribution for the aromaticity. So I think most of problems in your mind will be may be solved. So if you have a question, please leave a comment and please subscribe my channel. Thank you.